So next we're going to talk about VMM integration, and VMM stands for Virtual Machine Manager. So when we talk about VMM domains, we're talking about things like vCenter, vShield, Microsoft SC VMM, and then OpenStack Nova, for instance. So there's quite a bit of Virtual Machine Manager integration we can do. Within our lab and with all my demos, we're going to be talking about VMware's vCenter. It's probably going to be the most common, though I probably will see as we get to deploy this more and more, see a lot of Microsoft out there as well. So let's hop right into this. We have the ability to integrate ACI with these specific virtual machine managers. It is I will actually say it's one of the most impressive features about the system because we can integrate with these guys, and we're actually going to be building a distributed virtual switch through the use of their API. We also are going to see that I have right here, multiple VMM domains are supported on a single fabric. So we could actually have, System Center VLAN, domains, VMware vCenter domains. And we have the ability to basically map, from those specific hypervisors, we can accept VLAN tags, VXLAN tags, or even NVGRE. So we have quite a bit of flexibility there, and through that process that we talked about called normalization, okay, we're going to take the tags from these guys, and we're going to be able to, ultimately, there's going to be some internal mapping going on. We're going to be able to map those to specific endpoint groups within the ACI fabric. So again, through that process of normalization, we can accept those specific tags. With regards to our demo, we're going to be creating what's known as a VLAN pool. Know that we could do, remote VXLAN or VTEP tunnel endpoints. And then if you're running a Microsoft system, we have the ability to accept NVGRE. So there's, again, quite a bit of flexibility with regards to these guys. Now, the process for this, I think, personally, it's not too bad. We're going to be basically the administrator. So, us or whoever's configuring this guy, we're going to be logged into the APIC. So again, using most likely it's going to be HTTPS, though you could build this using some sort of scripting engine. But we're going to be in the APIC GUI. And what we're going to do is we're going to supply a couple of things. For instance, we're going to tell it, if we're using vCenter, for instance, we're going to tell it the IP address. We're going to tell it the data center name that we're going to be building the distributed virtual switch in. We're also going to be coming in and we're going to give it some credentials. Okay, so if, I think I'm going to use the actual root, but you could create another user to leverage. But those three things are going to be able to point the APIC, at the API, specifically in this case of vCenter. Now, what this process does is we point it towards the IP, give it the credentials, and actually put in the data center name that we want to build within, is it's going to come in and build a distributed virtual switch within vCenter, okay, and more specifically within that data center name that we actually gave it. Now, this is kind of cool. We could run the virtual the DVS, as they call it, the distributed virtual switch. I kind of put it in wrong. Or you could run the Cisco AVS if you so chose. Again, in our demos, we're going to be using the DVS within vCenter. And then what we can do after that is we can actually map endpoint groups based on this VMM domain, okay? We could create the endpoint groups, and what it's going to do is it's going to create a port group within vCenter. And, this is kind of cool because, as we go in and we have our individual VMs, what we do, again, this is going to be done through vCenter typically, is we place these individual adapters within a port group on that distributed virtual switch. Now, that port group is based, again, on the endpoint group that we created. So as we go into the APIC, and notice I have the arrow going from actually, let me clean this up just a little bit. Notice I have the arrow going from the APIC to the EPG because we create that EPG within the APIC. Okay, it pushes that config down to vCenter, and vCenter creates these port groups. Okay, so now we have these port groups hanging off of this distributed virtual switch. When we go into the VM properties, we can place these adapters within their respective port groups. So it's a very close-knit relationship. Now, the reason that we're able to do this is we create what's known as a VLAN pool, okay, within the APIC. And if you remember our VLAN pool discussion, this is going to be what we refer to as a dynamic VLAN pool. Okay, meaning we're typically going to give it a range. We might say 50 through 100, depending on the number of endpoint groups that we kind of intend to create towards that VMM domain. And as we create those EPGs, basically vCenter will just, or the APIC will actually dole out and say, hey, you use VLAN 50. So we may come in and this user port group is going to be using a VLAN tag of 50, and maybe this guy's going to use 51. It's not a good color, red on red, right? So what we do here is we take this VLAN, and as we come in from a specific host, we're going to use that VLAN to map to that respective endpoint group. So if we had 50 come in over here, it would be mapped to this endpoint group. If we had 50 come in over here, we would be mapped to this specific endpoint group. And I meant to say 51, sorry about that. But if you think about the grand scheme of things, this is coming from an ESXi host, right? It's not coming, these VMs aren't actually riding on vCenter. These are going to be hosts that kind of hang off of your leaf switches. So what happens is we may have, a leaf switch over here, and I'm just going to do one ESXi host as an example. So we may have, leaf 1, for instance, and he may have 2 ports here going down to this ESXi server. Okay, we'll just call this guy ESX1. And maybe this guy has, VM1 attached to him. Maybe he's got VM2 attached to him. What we're going to do is we're going to be able to discover these specific VMs and our specific hosts using LLDP or CDP. Now, I'll tell you by default, we're going to be trying to use LLDP. There are some instances, especially if you're using B-series servers, I should say B-series UCS servers, or even some select C-series UCS servers. I know, for instance, the P81 VIC card has some issues. They will not actually pass LLDP past the actual adapter themselves. So if these guys are riding on, say, a P81 VIC card, LLDP will run down to the host, but what won't happen is they won't pass those LLDP frames down towards the actual virtualized systems. And we need that to happen. We need some form of communication down there to have visibility down at the actual virtual machine level. Because remember that VMware distributed virtual, there we go again. I keep doing that. I keep hitting these stupid buttons. There we go. Let me see if I can delete that. We won't actually pass it down there, and we won't have visibility down to these individual VMs, which is a problem. So we'll see with some specific UCS systems, we actually have to stop the propagation of LLDP and use CDP in order to discover that virtualized infrastructure back there. And I think we're going to actually have to do this in our lab because I think we're messing with some C-series servers that actually have the P81 VIC cards in them. So we'll probably see this in action, but no, most of the time it is perfectly fine just to discover everything down through the actual adapters on the physical servers into the virtualized system based on LLDP, which is the default. Okay, so let me go back to transparent here. Get rid of that. So again, at that point, once we create those endpoint groups, we're just going to go into maybe this virtual machine's properties, and we're going to say, hey, this specific adapter is going to be a part of this port group, and thus he's going to be mapped to that endpoint group. Make sense? Now again, if we had these two VMs, even though they were attached to the same DVS, if we wanted to allow communication between those two, we'd have to have some sort of contract in place, and again, that's going to require an application network profile, but that contract would have to be in place. We'd have to be providing it from the web EPG, consuming it from the user EPG, in order to allow communication, say, from this EPG through here and down to this specific VM. So again, we still have to have those basic constructs in place in order to allow that communication. Now, I put together a little flowchart. I will be providing these slides so that you guys can kind of use these as reference if you guys are doing specific tasks. We're going to go through this in excruciating detail in the next demo, but typically the process that I go through, because there's a little more to it than I just depicted in that last kind of animation, what we're going to do is we're going to create, a dynamic VLAN pool. That's typically the first thing that I do. Make it big enough to accommodate all of the different EPGs that you anticipate being hosted from that VMM domain. So if you know you're going to have 60 port groups, make sure that you have at least 60 VLAN, 60 VXLAN, 60 different NVGRE tags coming in. Make sure you're able to accommodate all those. The next thing I typically do is I'll create the VMM domain. And if you kind of follow my subchart, within there, you're going to reference a VLAN pool. If you're using security domains as like a security-based or role-based access control identifier, you could do that. And then you're going to enter your vCenter credentials, IP address, and I'm also going to append to this the data center name, because that is a part of that. You do have to basically tell the system what data center it's going to be building the DVS within. We also have, once we complete that process, we have to go into vCenter. And again, I have kind of the brackets here to annotate that that's going to be done in vCenter. You have to add that host to the DVS. And part of this process is you're going to come in here and you're going to give it some physical NICs, okay, that you're going to use as uplinks. Okay, so you're going to point out some physical NICs that are going to be the uplinks for that specific host on that distributed virtual switch. You'll have the ability, if you want, to go ahead and migrate VMs, migrate VM kernel ports within there. I typically don't do that on the first go round. If you want to migrate them later, you can. But what I do is I typically just migrate the physical NICs first that are going to be basically the uplinks. After that, I typically go in and I'll add that VMM domain to an attachable access entity profile, create the EPGs, and then put the ports, misspelled group. Shouldn't highlight my mistakes there, right? Typically you go in and you'll actually add the virtual machines VNICs to an EPG based on a port group designation, okay? Once you do that, I have finished here. That's not really where we finish, right? Because your VM's not going to be able to communicate unless you have that other application structure set up. So you're going to have, your app profile, of course, to even have your EPGs, but then you're going to have your contracts in place in order to allow those EPGs to even communicate in the first place. So we are actually going to build out a fully fledged VMM domain. Again, ours is going to be based on vCenter. Yeah, I don't have it. I don't have the picture in here. I'll bring up the picture when we actually start to set up that demo here in just a minute. But basically, we're going to integrate with vCenter. I'm going to have a 3-tiered app set up on that vCenter domain. So I'm going to have an app server, a database server, and a web server. We're going to put all those guys in different port groups. So it's going to be a fully fledged virtual machine manager or vCenter domain. We've got an ESXi host hanging off a C-series server. So I think we're going to end up running into those problems where we actually have to discover everything via CDP rather than LLDP. So we might go through some motions with that as well. But you guys will get to see all this in action and exactly how all that config is done.